Hello all of you. So let us start today's session. There is a slight delay because there is a problem with my system. I could not start in time. So anyway, I'll extend class till 2 o'clock. I try to finish up as much as I can. Okay. So in today's session we are going to see okay. Today we are going to discuss about hydrographs, unit hydrograph concept. Yesterday I started, but because of problem with my system, then I stopped it. Right? Suddenly, all of a sudden, I stopped it. But let us continue today's work. I don't have problem today. Let us continue our work. So today I am going to start unit hydrographs. We call it as UHZ. So I'm experimenting, I'm learning new things here. Where it has gone. Okay, I'm not comfortable with this kind of screen. Okay, let me go back to the original one. So let me go with my old style. I tried this is comfortable. Okay. So let us start. This is good. Unit hydrograph. So before the development of this unit hydrograph concept, hydrographs were used only for finding out runoff. Except runoff, nothing we used to get. But after the advent of unit hydrograph concept, then this total hydrology, the hydrological analysis completely revolutionized. So beyond runoff, many things we work out with the help of unit hydrograph. So direct runoff hydrographs are used only for estimating direct runoff. Beyond that, they are of no use. Okay. So directly you can work out direct runoff or simply runoff. So beyond that, it is of no use. But unit hydrograph concept has completely changed our thinking. So beyond runoff, we can work out floods well in advance. Flood forecasting we can carry out with the help of unit hydrographs, right? Storms related to different durations we can work out. Stam of one hydrograph is available. So with the help of that, we can also find out hydrograph for stamps of different durations. So many things we can work out related to catchments with the help of unit hydrograph concept. Unit hydrograph concept is something like a imaginary concept. So with the help of this imaginary concept, we try to travel back to reality. So reality we realize with the help of imagination. Okay, that's how unit hydrographs have become very, very popular. So unit hydrograph also a direct runoff hydrograph. Also a direct runoff hydrograph. Resulting from a storm of certain duration. Resulting from a uniform storm of certain duration. That is also important. Wording is very, very important to understand the concept. Resulting from a uniform storm of certain duration produce a runoff depth of 1 centimeter or unit runoff. In India, unit runoff means is 1 centimeter. Uniformly over entire catchment. For such storm, if you measure stream flow variation and if you plot the hydrograph, then the hydrograph obtained is known as unit hydrograph. So actually, everywhere the runoff accumulate in a catchment is 1 centimeter runoff. In entire catchment, everywhere runoff accumulate is 1 centimeter. For such a storm, if it is delivered that runoff into stream, it is a runoff accumulated in a catchment. Depth of runoff is how much it is? Runoff 1 centimeter. If this runoff if you deliver into stream, how exactly stream flow varies? It is ultimately delivered into stream. So that variation if you plot at a point in a stream, then hydrograph that we obtained is called unit hydrograph. This hydrograph what we get is called unit hydrograph. Shortcut we write it as UHZ. So a rain is occurring for certain duration. Let us assume duration of rainfall is some D. So D hour storm has occurred. That D hour storm produces a runoff of how much? 1 centimeter. If that runoff if you drain into a stream, then exactly how that stream flow varies with respect to time, that plot if you make, that is called unit hydrograph. In shortcut we write it as UHZ. Unit hydrograph resulting from D hour storm. So storm to storm, it may vary. So storm information will give here. So D hour rain has occurred. It has produced that hydrograph. Okay. So this variation will plot. How discharge varies with respect to time. 1 centimeter runoff is delivered from a catchment. So that will give unit hydrograph. This unit hydrograph concept is proposed by Sherman. Unit hydrograph concept proposed by Sherman. Ludwig Sherman. Sherman based on two assumptions. This question also they are asking in competitive exam, JEE exam, SSC JEE exam and all. Sherman based on following two assumptions. Assumption number 1 is linear response. Assumption number 2 is time invariance. Time invariance and linear response assumptions are. So what is these two assumptions? You have to understand. These two assumptions also very popular in competitive exams. Linear response and time invariance. Linear response means, for example, if you see today early morning, if you go to market to buy some fruits, some apples you want to buy. So early morning, if you go to market, morning times normally you will find fresh fruit, right? So therefore their cost is very, very high. So you ask for what is the cost of 100 apple. So they may quote you some 1,000 rupees. But what we presume and assume is, if cost of 100 apple is 1,000 rupees, you want to buy cost one apple, so 1,000 rupees by 100. So cost of one apple is equal to 10 rupees only. But reality is different. If you want to buy only one apple, cost may be 15 rupees or 20 rupees. You want to buy 100 apple, then only cost is 1,000 rupees. You will get those apples, 100 apples for 1,000 rupees only if you buy bulk quantities, isn't it? But you want to buy only one, so you don't get for the same price. But what we presume and assume is 100 apple cost 1,000 rupees, cost of one apple is equal to 1,000 by 100, 10 rupees only. That is called linear response. Cost of one apple is 10 rupees, cost of 5 apple is equal to 50 rupees. That's how we work out. So exactly same way, if 1 centimeter runoff produces discharge of so and so cubic meter per second, if 5 centimeter runoff catchment yield, then how much amount of discharge we can find in the stream, that we can work out by using linear response assumption. So 1 centimeter runoff from a catchment produces a stream discharge of 10 meter cube per second. If a catchment produces a runoff of 5 centimeters, then stream discharge would be or could be anywhere. So it is 10 meter cube per second for 1 centimeter. Therefore 5 centimeter, how many cubic meter per second? So 10 into 5, 50 meter cube per second. Like that we can work out. That's called linear response. It may be true, it may not be true, it may be, but it is almost very close to the reality. That's why these assumptions are valid. Time invariance. Time invariance means what? We inquired cost of 100 apple in the morning. Right? Morning it cost, 100 apple cost 1,000 rupees. Same 100 apple you want to buy late evening or sometime 10 o'clock in the night, if you go and inquire for the same apple, you can get for 700, 800 only, because fruits they decompose. They can't store it for long period. They are perishable things. So they can't keep them and maintain the cost forever same. So as time progresses, their cost come down. Fresh apple cost more, then slowly they become rotten, so they decompose. Therefore, as time progresses, cost will come down. But what we presume and assume, the cost remains same. Early morning also 1,000 rupees, late evening also 1,000 rupees, tomorrow also 1,000 rupees, after 1 week also 1,000 rupees, next month also 1,000 rupees, next year also 1,000 rupees. So that means what is independent of time. Cost is not changing with time. That's called time invariance. Exactly same way, when a storm occurs that produces a runoff for 20 hours, real storm, but an imaginary storm which produces a runoff of 1 centimeter, that do produce runoff for 20 hours. That's the meaning of time invariance. A real storm produces a peak discharge at some 6th hour or 7th hour after the commencement of the storm. That imaginary storm representing 1 centimeter runoff, that do produce peak at same time. That's called time invariance. So linear response and time invariance assumptions allow us to work out so many number of things related to real storms. So we can travel from real storm to imaginary storm to real storm. So real storm, hydrograph is represented by direct runoff. Hydrograph represent real storm. Okay, real storm represent direct runoff hydrograph. Okay, imaginary storm represent unit hydrograph. Unit hydrograph always represent imaginary storm. So we travel from reality to imagination, imagination to reality. So when unit hydrograph is given, we can derive direct runoff hydrograph. When direct runoff hydrograph is given, we can derive unit hydrograph. So real storms represent direct runoff hydrograph. Unit hydrograph represent an imaginary storm producing a runoff of 1 centimeter. Okay. So how to derive this direct runoff hydrograph based on these two assumptions? Let us see with the help of unit hydrograph. First of all, let us know how to derive unit hydrograph from real storm hydrograph. So real storm is normally storm hydrograph. Storm hydrograph is given to you. Let OS0, OS1 dot 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 OSN be the ordinates of, ordinates means discharge ordinates. Ordinates of D our storm hydrograph. And B be the base flow. This is known to you. So storm hydrograph represent real storm. So that hydrograph is given in terms of ordinates. So first ordinate is OS naught at time T naught. Second ordinate is OS1. Third ordinate is OS2. Like this, so many ordinates are given to you up to OSN. T naught, T1, T2, dot 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 Tn up to Tn. And B also given to you, that is base flow. So this is base flow, let us assume. This is base flow B. Okay, straight line method, whatever it may be. This is called storm hydrograph. So this represent D our storm. So from this what we need to do? So we derive first direct runoff hydrograph. Then direct runoff hydrograph ordinates is equal to, it is storm hydrograph ordinates at respective time intervals minus base flow. So therefore OD0, ordinate of direct runoff hydrograph at time T0 is equal to ordinate of storm hydrograph at time T0 minus base flow. OD1 is equal to OS1 minus base flow. Like that, n number of ordinates we can derive. So OSN minus base flow. So this is how we can derive ordinates. So we got one direct runoff hydrograph. So direct runoff hydrograph is the one which start with 0, end with 0. This is OD0, OD1, OD2, OD3, ODN. So ODN and OD0 happen to be zeros only. These are time T0, T1, T2 up to Tn. So this is called direct runoff hydrograph. We obtain one direct runoff hydrograph. But what is our idea? We have to derive one unit hydrograph. Unit hydrograph to derive what to do? So time invariance and linear response assumptions we use. So unit hydrograph ordinates are obtained. So for 1 centimeter, this is ordinates. Direct runoff hydrograph ordinates represent R centimeter runoff. Unit hydrograph ordinates represent 1 centimeter runoff. For R centimeter, ordinates are OD0, OD1, dot 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 ODN. For 1 centimeter runoff, ordinates are so OU0, OU1, then OUN, something like that. So how to derive them? So derive the ordinates of unit hydrograph. Once 5 R centimeter produce that much amount of runoff. 1 centimeter produce how much amount of runoff? 5 mangoes cost 50 rupees. What is the cost of 1 mango? 50 by 5, something like that. So R centimeter produce that much amount of discharge. 1 centimeter produce how much amount of discharge at respective time intervals. So this is how we can work out. Then we derive the ordinates of, so derive the ordinates of unit hydrograph at respective time intervals by dividing direct runoff hydrograph ordinates by runoff R. So unit hydrograph ordinates is equal to, it is direct runoff hydrograph ordinates by R. So that means what? So OU0 is equal to OD0 by R. OU1 is equal to OD1 by R. At respective time intervals, if you subtract, then you get unit hydrograph ordinates. So that means we got one unit hydrograph with ordinates, right? This is OU0, OU1, OU2 up to OUN at time T0, T1, T2, Tn. This is unit hydrograph ordinate, unit hydrograph. D hour unit hydrograph. This represent D hour stop. That's how we write. So this also represent same D hour stop, but this unit hydrograph. This also represent same D hour stop, but this is direct runoff hydrograph. This represent D hour stop, but this is storm hydrograph ordinate. So this is how we can travel. So whenever the kind of question they ask is, question could be, so storm hydrograph is given to you along with base flow. Okay, this is also given. Then you are expected to find out unit hydrograph. Then what to do? So first we derive direct runoff hydrograph is equal to, it is storm hydrograph minus base flow. That will give direct runoff hydrograph. Then unit hydrograph is equal to direct runoff hydrograph by runoff R. So how to find runoff? Once direct runoff hydrograph is known to you, R is equal to, it is volume of runoff by catchment area, that will give R value. How to find volume of runoff? Area of direct runoff hydrograph. Area of direct runoff hydrograph by catchment area A. If you divide, you will get R. So if you divide those R by unit direct runoff hydrograph ordinates, if you divide by R, you will get unit hydrograph ordinate. This is one type of question. Question type 1 it is. So some other type of question is type 2 type of question, where unit hydrograph will be given to you. Then you are expected to find out storm hydrograph or flood hydrograph given along with pi index. Then you are expected to find out storm hydrograph or flood hydrograph. So what to do? Then using pi index, what you can find out? Runoff. Pi index is equal to P minus R by T. Everything is given to you. T is nothing but D, storm duration. So from this you can find out R. Then once you get R, then we can find out direct runoff hydrograph ordinates. Direct runoff hydrograph is equal to this storm hydrograph, unit hydrograph is given, right? So then we can find out direct runoff hydrograph. Direct runoff hydrograph is equal to, it is unit hydrograph into R. Then once you get direct runoff hydrograph, then you can get storm hydrograph or flood hydrograph, which is equal to direct runoff hydrograph plus base flow. If you add base flow, you will get that one. That's all. Okay? So indirectly information is available to find out R. Type 1 question, type 2 question. And one more type of question that you can expect here is, whenever unit hydrograph is given to you, you are expected to find out catchment area. In that case, how to work out? So since unit hydrograph also a direct runoff hydrograph representing a runoff R 1 centimeter. Since unit hydrograph also a direct runoff hydrograph, therefore area under unit hydrograph also represent volume of runoff. Since it is unit hydrograph, this represents a runoff of 1 centimeter. So therefore catchment area is equal to, therefore volume of runoff we got, catchment area is equal to, this is depth of runoff. Catchment area A is equal to, it is volume of runoff by depth of runoff. What is volume of runoff? Area of unit hydrograph. Area of unit hydrograph we measure, and if we divide by depth of runoff 1 centimeter, which is nothing but 1 by 100 meters. So this will get in meter cube, this in meter. then you will get catchment area in meter square. You want to convert into kilometer square, divide by 10 power 6, then you will get catchment area in kilometer square. Or if you divide by 10 power 4, you will get catchment area in hectares. So this is another type of question they are asking. So 3 types of questions are very popular related to unit hydrographs of given storm of d hour duration is. So whenever storm hydrograph or flood hydrograph is given to you, you are expected to derive unit hydrograph, this one. Okay? Then you are expected to find out unit hydrograph. Whenever unit hydrograph is given to you, you are expected to find out storm hydrograph or flood hydrograph. Okay? Then storm hydrograph or flood hydrograph is equal to direct runoff hydrograph plus base flow. For that, there is a information to work out runoff also. Then third type of question is whenever unit hydrograph is given to you, you are expected to find out catchment area. Therefore, area under unit hydrograph also equal to volume of runoff. That point you remember, then you can work out. Unit hydrograph always represent runoff 1 centimeter. Therefore, it is taken as 1 by 100 meters. 1 centimeter is equal to how much it is? 1 by 100 meters. Okay? So 1 by 100 if you substitute, volume of runoff by depth of runoff will give catchment area. So this is how they'll frame questions in the exam. So let us solve few questions, then you are more comfortable. So 3 types of questions you can expect in the exam. Okay? One is whenever with the help of this diagram you can better understand. So this is one. So sometimes what he does, he will give you storm hydrograph. He will give you this. Okay, with base flow and all. Okay, from this what we derive? We derive one direct runoff hydrograph. So because time invariance and linear response, shape will be same but ordinates are different. Why shape is same? So these ordinates of direct runoff hydrograph we obtain just by subtracting base flow. Assuming base flow to be constant, then shape will be same. So this is direct runoff hydrograph. From this what you can derive? One unit hydrograph also we can derive. This is our unit hydrograph. So this is storm hydrograph or is also known as flood hydrograph. The second one is, this is direct runoff hydrograph representing same storm, and the last one is, this one is unit hydrograph. So where peak of unit hydrograph is there only peak of direct runoff hydrograph also you can notice. So that's the meaning of time invariance. So where peak of unit hydrograph is there, here somewhere here, there only you can find peak of direct runoff hydrograph. There only you will find peak of storm hydrograph or flood hydrograph. So finding peaks. So this is, what is this? This is peak coordinate of storm hydrograph or flood hydrograph. Then there only you will find peak coordinate of direct runoff hydrograph. There only you will find peak coordinate of unit hydrograph as well. So here only you will find peak coordinate of unit hydrograph. So all the peaks are occurring at same time. So therefore this is a time invariance. So both assumptions, time invariance and unit, this is cube meter cube per second. This is time in hours. Okay. So at any point of time, so you can work out. Whenever storm hydrograph is given, you are expected to find out direct runoff hydrograph. From there, you are expected to find out unit hydrograph. Whenever unit hydrograph is given, you are expected to find out direct runoff hydrograph. From there, you can find out storm hydrograph or flood hydrograph. Understood now? So therefore, finally what you have to remember? So direct runoff hydrograph is equal to, it is storm hydrograph minus base flow, and unit hydrograph is equal to, it is direct runoff hydrograph by R. Okay, or direct runoff hydrograph also equal to, it is unit hydrograph into R, then storm hydrograph or flood hydrograph is equal to, it is direct runoff hydrograph plus base flow. So this way or that way we are forced to travel. So whenever direct runoff hydrograph is given, you are expected to find out this. Whenever unit hydrograph is given, you are expected to find out storm hydrograph and flood hydrograph. That you can find out. So this much idea is there, more than sufficient. In between the link is R. So how to work out that R? Sometimes to find out this R, we require direct runoff hydrograph. Sometimes to find out that R, what require? You require pi index or double index. If that is given, you can find out R value. So R value you can find out by using pi index. Pi index is equal to, it is PE minus R by TE. So from this you can find out R. So R also equal to, it is area of direct runoff hydrograph by area of direct runoff hydrograph by catchment area, that also will give R value. So this way also you can find out R. This much idea is there. Any question from any book you can work out related to unit hydrographs of a storm of given duration. Let us work out few questions, then it will be very, very comfortable to you. Shall we go ahead with solving questions? Yes, I'll come there. So for time being, you wait. Okay, now let us see few examples. If you solve, then you will be very comfortable. So let me try one question. This question is been asked in ESE 2006. ESE question. A 4-hour unit hydrograph. UHG means unit hydrograph. We need not write always elaborately writing this. A 4-hour unit hydrograph. You can write UHG of a basin. Basin means catchment. Can be approximated as triangle. Triangle with a base period of 40 hours. And P coordinate of 300 meter cube per second. What is the area of catchment? Come on, try. Come on, Rahul, and all try this question. So what is given to you is unit hydrograph is given. It's in the form of a triangle with a peak discharge of 300 meter cube per second. Of course, he has given options. At a base of 48 hours. 4-hour unit hydrograph represent 4-hour storm. So we'll write here storm duration, 4-hour storm. Okay. So options given are, so option A is 7776 kilometers square. Option B is 5184 kilometers square. Option C is 2592 kilometers square. Option D is 1294 kilometers square. So these are the options given to you. Okay, let us see how to work it out. So how to find out volume of runoff? So volume of runoff produced by this 4-hour storm is in a catchment is area of 4-hour unit hydrograph, or area under 4-hour unit hydrograph. So it is a triangle in shape half into B into H. So this is multiplied with 60 and 60 because this is in meter cube per second. So this value also converted into seconds. So second get cancelled. You left with so and so meter cube. So this will get in meter cube volume. And depth of runoff. Since we are taking unit hydrograph as a reference, so depth of runoff R is equal to always 1 centimeter because we are using unit hydrograph. Since it is unit hydrograph. If it is direct runoff hydrograph, R may be more than 1 or less than 1. So exactly 1 centimeter means by default it is unit hydrograph. So therefore catchment area 1 centimeter means it is 1 by 100 meters. Therefore catchment area of basin is equal to, or catchment area of the basin is equal to, basin means catchment only, is equal to, it is volume of runoff by depth of runoff. Very good, Deepak. Okay, so volume of runoff, it is half into 300 into 48 into 60 into 60. Of course, I don't have space here. So you'll get answer in meter square, then convert into kilometer square. So it is half into 300 into 48 into 60 into 60, the volume. Depth of runoff is 1 by 100. So meter cube by meter, you will get answer in meter square. To convert this into kilometer square, we divide by 10 power 6. Come on, you will get answer 1 by 10 power 6. So 0.5 into 300 into 48 into 60 into 60 into 100 by 10 power 6. How much it is? (2592 kilometers square). See now, Deepak is given 5184. That is wrong answer, no Deepak? It is 2592 kilometers square. So therefore answer is what? 2592. Deepak, correct you. Correct. So that's 40 you write. It has 48. That's 40, not 40. 48 hours it is. It is given as 48 hours, no? This is 48 hours. But what I wrote 48 only I wrote to Deepak. You took it as 40. It's not 40, 48 it is. So this IES question, IESE 2006 question. Okay, this was the answer for that question. Let us try one more question, Deepak, so that we will be comfortable. This is also ESE question. Without calculator you can manage. ESE 2007 this is. A unit hydrograph for a watershed is triangular in shape base period of 20 hours. The area of the watershed is 500 hectares. What is the peak discharge in meter cube per hour? Options given are 7,000, 6,000, 5,000 and 4,000. Come on, work out all of you. Last question answer is what? 2592, right? Come on, all of you try. If I only solve, no use. So you should solve from your side. Answer should come from your side. Okay, so it is a triangular 20 hours base, peak discharge is not given, that you have to find out. I'll assume that this peak discharge is QP, meter cube per hour. This is unknown, that you have to find out. Okay. Base is given as 20 hours. What is peak discharge is asking. This is representing a catchment of area 500 hectares. This hydrograph representing a catchment of area 500 hectares. 500 hectares is how many meters square? 500 into 10 power 4 meters square. Since it is unit hydrograph, runoff is equal to 1 centimeter. It is 1 by 100 meter. So therefore, so volume of runoff is equal to, how you can find out volume of runoff? So area of unit hydrograph, if it can take volume of runoff, which is also equal to catchment area into depth of runoff. That also will give volume of runoff. What is area of unit hydrograph? It is half into QP into 20. Because this is in meter cube per hour, so this is in hours. So no issue, no need of any conversion. 60-60 division is, multiplication is not required. Is equal to catchment area is 500 into 10 power 4 meters square. This is in meters square into 1 by 100 meters depth of runoff. This is in meters. So this side also meter cube, that side also meter cube. The only unknown is QP. QP value you can find out. Come on, work out QP value. Therefore QP is equal to P coordinate of unit hydrograph. So it is 500 into 10 power 4 into 1 by 100 by, so half into 20. Come on, work out, try it, will get answer in meter cube per hour. So I got 5,000 meter cube per hour. So that was the answer for this question. $5,000 is there or not in these options? It is there. So we'll tick mark that. Clear now? Concept is clear? Very good, Deepak. This time you are Absolutely right. Now let us try one different kind of question. Okay. This question also asked in GATE exam. For a catchment, a 2-hour unit hydrograph is in the form of triangle. With a base of 40 hours and peak of 10 meter cube per second. Peak means peak ordinate. For same catchment, a 6-hour unit hydrograph derived, which is in the form of triangle with a base of 44 hours. Then what will be the peak of the 6-hour unit hydrograph? Then what will be the peak of 6-hour unit hydrograph? That was the question. Come on, try this question. Try all of you. Wanted to show you something which Unacademy is offering. Completed that question? So in that question what is given to you is a 2-hour unit hydrograph is given. Two-hour unit hydrograph represent 2 hours storm which has got a peak discharge of 10 meter cube per second with a base of 40 hours. Same catchment receives a 6-hour storm which has got a peak base of 45 hours producing a runoff for 44 hours. So what is the peak discharge of the storm he is asking. So let us assume this in meter cube per second. He is asking this in meter cube per second. Okay, this represent 6-hour storm. So both storms are occurring on the same catchment area is same. Both storms have occurred on the same catchment, therefore catchment area is same for both storms. 2-hour storm and 6-hour storm. So this represent 2-hour storm. This represent 6-hour storm. This hydrogram. Both have occurred on the same catchment. Different time periods. So therefore catchment area is same for both storm. Therefore catchment area is same. Same for both storm. So using first catchment area, I will work out something related to second storm. So what is catchment area? Catchment area is equal to the volume of runoff by depth of runoff. So volume of runoff is area of unit hydrograph. Depth of runoff is always unit hydrographs 1 by 100 by 1 by 10 power 6 you take, you get catchment area in kilometer square. Okay, so therefore I can write this equation as like this. So catchment area A is equal to, it is area of 2-hour unit hydrograph by 1 by 100 into 1 by 10 power 6 kilometer square, which is also equal to area of 6-hour unit hydrograph by 1 by 100 into 1 by 10 power 6 kilometer square. So almost all of them cancel out. Okay, they cancel out. Then what you left is area of 2-hour unit hydrograph. What is area of 2-hour unit hydrograph? Half into 10 into 40 into 60 into 60. Area of 600 hydrograph is half into QP into 44 into 60 into 60, because this is producing runoff for 44 hours, this is producing runoff only for 40 hours. Therefore QP is equal to, so half of also get cancelled, 60 also get cancelled, therefore QP is equal to, it is 10 into 40 by 44 meter cube per second. Come on, how much it is? That's how we can work out. 10 into 40 by 44. So it is 9.09 meter cube per second. So what I mean to say is, though both of the storms are occurring on the same catchment, because of durations are different, so no two storms produce same runoff. No two catchments also produce receiving same storm. They yield different kind of hydrograph. So storm to storm hydrographs are different. Catchment to catchment also hydrographs are different. That point you have to keep in your mind. No two stamps produce same type of hydrograph. No two catchments also produce same type of hydrograph. Catchment to catchment things are different. Stamp to stamp things are different. Understood now? So this is how we can solve this question. This kind of questions more they are asking in GATE exam nowadays. Okay, anyway, one more superb question let us solve. If this question is solved, then we presume and assume that you have got good idea of this subject. This question also asked in GATE exam. This example, I think it is 4. It's a old GATE question. So what is given to you is a two-oriented hydrograph ordinates are given below. So time in hours. And discharge in meter cube per second. 0, 0. After 1 hour, 5. After 2 hours, 15. 3 hours, 12. 4 hours, it is 10. 5th hour, it is 6. And again 6th hour, it is 0. This is given to you. And what you are expected to work out? If a storm of 4.2 centimeters occur in 2-hour duration over the catchment, and pi index is 0.8 centimeter per hour, calculate 1. The maximum discharge of the resulting direct runoff hydrograph. Maximum discharge means peak coordinate only. Second question, the maximum flood discharge. If base flow is 7 meter cube per second. That was the question. Come on, if you solve this question, I can understand that you got full idea of the subject, this topic. So what is given to you? 7. This is given to you. I am giving idea. What is a unit hydrograph? Because ordinates are given, that means it is non-linear. This is 2-hour unit hydrograph. So where there is a peak of 2-hour unit hydrograph, there only peak of, right, direct runoff hydrograph also occur. So how to get direct runoff hydrograph peak? Unit hydrograph peak plus base flow. Unit hydrograph ordinates into R. That will give direct runoff hydrograph. So this is direct runoff hydrograph. So direct runoff hydrograph is equal to, it is 2-hour unit hydrograph into R. That will give direct runoff hydrograph. Once you get direct runoff hydrograph, you can also find out flood hydrograph or whatever it may be. So the peak coordinate of direct runoff hydrograph. This is second question answer. This is. Third question answer is, what is third question answer? He is asking this. This peak coordinate, base flow is given. What is this? So this is 2-hour flood hydrograph or storm hydrograph. I have given hint to you. So time invariance assumption is valid, no? Where there is a peak of unit hydrograph, there only peak of direct runoff hydrograph, peak of maximum discharge. Where maximum discharge of unit hydrograph is there, there only maximum discharge of direct runoff hydrograph, maximum flood discharge also occur. What is maximum flood discharge here? 15. This is peak, maximum discharge of unit hydrograph. So therefore, P coordinate of 2-hour unit hydrograph, that is maximum discharge of 2-hour unit hydrograph. So that is there in the question from the table, 15 meter cube per second. Okay, it is given in the question, only given, that is 15 meter cube per second. This is maximum among all values, whichever is maximum, that is P coordinate. That is P coordinate of 2-hour unit hydrograph. Where peak of 2-hour unit hydrograph there only peak of direct runoff hydrograph also occur. What is first question? Maximum discharge of direct runoff hydrograph. For that, what is given? Pi index also given to you. So pi index is given to find out runoff. So pi index is equal to is PE minus R by TE. So here PE. So producing a storm of 4.2 centimeter. A storm of 4.2 centimeter. What is this value? PE value this is. So this is 4.2 centimeter. Duration of storm is 2 hours. 2 hours storm it is. Therefore, pi index is given as 0.8. So 4.2 minus R by 2. From this you can find out R value. So R is equal to 2.6 centimeter. Therefore, you can find out P coordinate of 2-hour direct runoff hydrograph, which is nothing but maximum direct runoff hydrograph, maximum discharge of resulting direct runoff hydrograph. Which is equal to P coordinate of 2-hour unit hydrograph into R. So P coordinate of 2-hour unit hydrograph is how much it is? 15 into 2.6. 15 into 2.6, how much it is? Can work out. 39 meter cube per second. Very good. 39 meter cube per second. Then where? Then he is also asking maximum flood discharge. Maximum flood discharge is nothing but P coordinate of 2-hour flood hydrograph. So maximum flood discharge is equal to nothing but P coordinate of 2-hour flood hydrograph. So where P coordinate of 2-hour direct runoff hydrograph, to this if you add base flow, then you will get a maximum flood discharge. So we got this 39, base flow is given in the question as 7, so it is 46 meter cube per second. That was the answer for second question. Understood now? Very good, Deepak. Keep it up. So that's how we have to work out. Now one more good question let me solve. This is also given in GATE exam. Example 5. Of course, that time they used to ask for 5 hours question. This is the successive three hourly ordinates of a 6-hour unit hydrograph for a particular base in R. Zero, 15, 36, 30. These are the ordinates. 17.5, 8.5, 3, cumecs respectively. Cumecs means meter cube per second. The flood peak observed due to a 6-hour storm is 150 cubic. Assuming a constant base flow, of 6 cubic and an average storm loss of 6 mm per hour. Then what I have been asked to find out is determine the depth of storm rainfall. Second one is the stream flow at 15th hour. This is a good question. So what we have been asked to work out is depth of storm rainfall. Storm rainfall means what? P value. Rain is occurring over a catchment. What is the rainfall value occurring in a catchment? Depth of storm rainfall means PE. Stream flow at 15th hour means what? P coordinate of storm duration is our 6-hour flood hydrograph or storm hydrograph. Is asking two things. This and this are unknowns. Come on, work out. Let me see how many of you work out this single question. If you solve, more than sufficient for you. Any question you can work out in any exam. Yes, base flow is always constant. So normally any variation is there in base flow will give you. Otherwise it is assumed to be constant. Even it is not given also will take base flow as, because if it is storm hydrograph, it should or unit hydrograph or any hydrograph, it should start with 0, end with 0. So start with 0, end with 0 means base flow should be constant. Then only it happens. Different base flow is there, it can't be a 0. So normally base flow is constant. Previous slide, okay, no issue. So I'll explain you, listen now. So he has given ordinates of unit hydrograph. So ordinates of unit hydrograph is given to you. 0 first one, the last one also 0. In between 15, 36, 30, 17.5, 8.53. Hydrograph is like this. So first ordinate is 0. Second ordinate is 15, third ordinate is 36, 30, 36, 30, 17.5, 8.5, 3 and 0. 36 this is. 30, then 3 more are there now. 17.5, 8.5, 3. So this is 17.5, 8.5, 3 and 0. Not to scale, 17.5, 8.5, 3 and 0. So like this he has given ordinates. So ordinates are given. One ordinate takes successive 3 hourly time intervals. That means what? So first one is 0, then 3, 6, 9, 12, 15, 18, 21. So runoff is there up to 21 hours. So catchment is draining runoff for 21 hours. This is 6 hour into hydrograph. This is given to you with ordinates. Okay. So with the help of this, what you have to find out? Storm rainfall, PE. Then 15th hour, peak ordinate of 16 hours, storm hydrograph or flood hydrograph. So QP of storm hydrograph you have to find out. Peak ordinate of. So unit hydrograph peak is known, that you can find out. First of all, let us work out. So what else is given? Base flow is given. Constant base flow 6. Storm loss, average storm loss is given. Average storm loss means that is infiltration loss. So instantly, what is the storm loss that occur in a catchment? Except infiltration loss, no loss is instantly happens. Isn't it? So storm loss, average storm loss is nothing but average rate of infiltration. What is the average rate of infiltration? For uniform storm, it is pi index and W index. Both of them same. Indirectly, it is pi index. Its value is given as 6 mm per hour. Okay? That's all. So pi index is given to find out PE. But unless R is known, you can't find out PE. So peak coordinate of 6 hour unit hydrograph is equal to maximum discharge of unit hydrograph. Among all, maximum value is 36 meter cube per second. Okay. Then what else is given? He also given in the question. The peak flood observed due to 6 hour storm is 150. So that means peak coordinate of 6 hour flood hydrograph. That means peak flood discharge. The river. This is given as 150 meter cube per second. And base flow is given as 6 meter cube per second. So therefore peak coordinate of 6 hour direct runoff hydrograph is equal to, it is peak coordinate of 6 hour flood hydrograph minus base flow. So it is 150 minus 6. So it is 144 cubic meter per second. Therefore, peak coordinate of 6 hour unit hydrograph is equal to direct runoff hydrograph ordinate by R. So peak coordinate of 6 hour direct runoff hydrograph is equal to peak coordinate of into R, right? So therefore, this is known to you, 144. The peak coordinate of 6 hour into hydrograph also known to you, 36. This is 36 into R. Therefore, R is equal to 144 by 36. It is 4 centimeter. Right? 1 centimeter 36 for 4 centimeter peak coordinate is 144. Including base flow, it is 150. That's what is given. Therefore, average storm loss pi index is equal to, it is PE minus R by TE. Here TE is equal to 6 hour storm, duration of storm. 6 hour storm means duration of storm is 6 hours. Okay? So this is given as 6 mm per hour. So P is unknown, R is unknown, this is 6 hours. So from this you can find out R we got now already 6 centimeters. R we got 4 centimeters. So let us convert this into centimeters. which is equal to 0.6 centimeter per hour. So this is 0.6 centimeter per hour. PE, R is 4 centimeters, T is 6 hours. So from this, PE is equal to 0.6 into 6 plus 4. So it is 7.6 centimeter. That was the answer for this question. Come on, Deepak. Answer is not there. That is the answer for first question. What is our first question? Depth of storm rainfall P is equal to 7.6 centimeter. Okay. Second question answer. The stream flow at 15th hour. So at 15th hour stream flow you have been asked to find out. That is stream discharge. So stream is carrying flood discharge. At 15th hour time interval, if you know the ordinate of unit hydrograph at 15th hour time interval, then you can also find out ordinate of direct runoff hydrograph at 15th hour time interval. Then from this you can also find out ordinate of flood hydrograph at 15th hour time interval. If you add base flow, you will get that. Base flow if you add, you will get that. So he is asking that one. This is flood discharge at 15th hour time interval. So ordinate of unit hydrograph at 15th hour time interval is how much it is? 15th hour time interval. What is the ordinate? 8.5. Here it is there given. .5 is the ordinate. From there we got no 8.5. 15th hour time interval we got already 8.5. This is. This into 4. You multiply, you will get this. This is 8.5 into 4. This will give direct runoff hydrograph ordinate. Then to this you add base flow. You will get 8.5 into 4 plus base flow 6. 6 are base flow. Base flow is given how much? 6. Then you get that one. What is that ordinate of flood discharge at 15th hour time interval? So ordinate of 6 hour unit hydrograph at time interval 15th hour. It is 8.5 meter cube per second. This is flood hydrograph this is. So ordinate of 6 hour direct runoff hydrograph at time interval 15th hour. It's the ordinate of 6 hour unit hydrograph at 15th hour into R. So 8.5 into 4. How much it is? 8.5 into 4. 34. But he is not asking that. What is asking? Ordinate of 6 hour flood hydrograph at time interval 15th hour, which is nothing but stream discharge at 15th hour time interval. Stream is carrying flood discharge. Stream is carrying flood discharge. Therefore, ordinate of 6 hour direct runoff hydrograph at a time T is equal to 15th hour plus base flow. So which is equal to, it is 34 plus 60. 40 meter cube per second. That was the answer for that question. So that is stream flow. Stream is carrying flood discharge. At 15th hour time interval is equal to is exactly 40 meter cube per second. That was the answer for this question. Understood now? With the help of that diagrams, table you take, still easily you can solve. How the table can be prepared? रन ऑफ कैलकुलेशन रिपीट करना है, करेंगे. Actually, I'll explain you with the help of table. Okay. So what is given to you is the travel from imagination to reality, reality to imagination kind of question this is. Okay. So this is one unit hydrograph is given. From unit hydrograph to direct run of hydrograph we can work out. To this, if you add base flow, you will get a flood hydrograph or storm hydrograph. Okay. Now let me post and you can better understand with the help of this diagram. So this is time. This is 6 hour unit hydrograph ordinates. They are given to you in meter cube per second. From this what you can find out? 6 hour direct run of hydrograph ordinates. How you can find out? 6 hour unit hydrograph ordinates into R. You will get that. To this you add base flow in meter cube per second. Then we will get what? 6 hour flood hydrograph ordinates, which is equal to 6 hour direct run of hydrograph ordinates plus base flow. So this is given to you. Successive 3 hour time interval 0, 3, 6, 9, 12, 15, 18, like that ordinates are given to you. Every 3 hour time interval one ordinate is given in the question. You can see there 0, 3, 6, 9, 12, 15, 18. 0 is not given, last ordinate is not given. 0, 15, 36, 30. So 0, 15, 36, 30, 36, 30, 8, 17.5, 8.5, 3. 17.5, 8.5, 3. Right? So where there is a peak of unit hydrograph, there only peak of direct run of hydrograph also occur. So where is peak coordinate of this one? Among all these ordinates, this is a peak coordinate. Exactly same place you will find peak of flood hydrograph. That is also given in the question. What is the peak of flood hydrograph given in the question? So this is given as 150. This is given as 150 cubic meter per second. Base flow is 6. So to get the 150 here, this should be 144. Okay? 144 plus 6 is equal to 150. To get this 144, 36 should be multiplied with R. So how much R should be there? So this R is equal to 144 by 36, 4 centimeter. That's how I got 4. Understood now? So I calculated like this. So P coordinate of 6-hour flood hydrograph is equal to, it is 150 meter cube per second. That is peak flood discharge in the river. From this out we can find out peak coordinate of 6-hour direct runoff hydrograph is equal to same time invariance linear response. Using those assumptions I am working out peak coordinate of 6-hour flood hydrograph minus base flow. So base flow given in the question 6. So this must be 144. Then using this what I can find out peak coordinate of 6-hour unit hydrograph is equal to, it is peak coordinate of 6-hour direct runoff hydrograph by R. Direct runoff hydrograph ordinates, if you divide by R you will get unit hydrograph ordinates. This is there in the question. Among all ordinates, peak coordinate of 6-hour unit hydrograph is what? This is a peak coordinate 36. So this is known as 36. Peak coordinate 6-hour direct runoff hydrograph, just now we got 144. Can't you work out R value? Therefore R is equal to 144 by 36, 4 centimeter. Understood now? Deepak? So if this is 4, then you will get. Similarly, you have been asked to find out what is peak coordinate of, what is the flood discharge in the river at 15th hour time interval. Flood discharge in the river at 15th hour time interval is equal to this one. This is the flood discharge, this one, this value. So this is 4 means automatically to get this runoff we got. How much we got runoff? 4 centimeters. So once you get 4 centimeter runoff, then 8.5 into 4, this is 32, 34. And this is 6, and this is 40. 34 plus 6, 40. So this is flood discharge, stream discharge at 15th hour time interval. Stream carry both direct runoff and as well as base flow. Stream carry both direct runoff and as well as base flow. Base flow also included in that. This is stream discharge at 15th hour time interval. Understood now? This is stream discharge at 15th hour time interval. Stream is carrying flood. Clear now, Deepak? Remaining not required for us. This is incomplete because other ordinates are not given. Because it is unit hydrograph, it should start with 0, end with 0. Remaining ordinates not required for us. I hope it is clear to you now. Come on, type there your comments. Type your comments there. Let us try one more question. This kind of questions only very popular, very confusing. Okay? Let us try one more. This is asked in GATE 2004 exam. Example 6. To make you understand, I wrote this much amount of information. But that much also not required. Once you are clear, straight away you can work out. GATE 2000 question, this is 2004 question. So what is given to you is the average rainfall. For a 3-hour duration storm. Storm is 2.7 centimeter and the loss rate is 0.3 centimeter per hour. The flood hydrograph has a base flow of 20 meter cube per second and produce a peak flow of 210 meter cube per second. The peak of a 3-hour unit hydrograph is. So I have been asked to find out something related to unit hydrograph. Options given are 125.5 meter cube per second, B 105.5 meter cube per second, C 77.77 meter cube per second, D 170.37 meter cube per second. Come on, work out. Let me see how many of you find out. So one or two questions, this kind of questions if you solve, that you will be clear with your concept. Average rainfall for a 3-hour duration storm is 2.76. Rainfall is given. So rainfall means what? PE. Solution. Rainfall, average rainfall means PE. Uniform storm. Average rainfall means it is a uniform storm. For uniform storm, pi index and W index, both of them are same. P is equal to how much is given? 2.7 centimeter. Duration of storm is T. T is equal to nothing but duration of storm. This is 3-hour duration storm, 3 hours. And what is given? Loss rate. Loss rate means what? Infiltration rate. Storm loss rate is nothing but pi index. This is given as how much it is? 0.3 centimeter per hour. So once pi index is known, can't you work out runoff resulting from this storm? P minus R by T. So 0.3 is equal to P minus P is 2.7 centimeter. T is 3 hours. So from this, R is equal to 1.9, 1.8, no? 1.8 centimeter, runoff that is. So what else is given? The flood hydrograph has a base flow of 20. So base flow of hydrograph is given as 20. 20 meter cube per second. Okay. Next, what else is given? The peak of they produce a peak flow of 210 meter cube per second. So peak ordinate of 3-hour flood hydrograph is given. 210 meter cube per second. And what is the question? Peak ordinate of 3-hour unit hydrograph. That you have to find out. Come on, where peak of flood hydrograph occur, there only peak of unit hydrograph also occur. That is the meaning of time invariance. So peak ordinate of 3-hour flood hydrograph is equal to, it is 210 meter cube per second. Then peak ordinate of 3-hour direct runoff hydrograph is equal to so it is peak ordinate of 3-hour flood hydrograph minus base flow. So base flow also given to you. How much is given? 210 minus 20. It is 190 meter cube per second. Then what is asking? So 190. Then once you get P coordinate of 3-hour direction of hydrograph, you can get P coordinate of 3-hour unit hydrograph, which is equal to P coordinate of 3-hour direction of hydrograph by R. If you divide this by R, you will get that one. So 190 runoff already calculated by 1.8. So 190 by 1.8 is equal to how much it is? So 190 by 1.8. So it is 105.5 meter cube per second, and that was the answer for this question. Okay. So we got the answer now. 105.5 is there here. So this is the answer for that question. Are you comfortable now in solving this kind of questions? If you are comfortable, it's okay for me. Otherwise, we will take up one more question. Okay then. So today I'll stop here. I hope we started at 11:40, right? 11:50 almost. 11:50 to 12:50, 12:50. I can take up to 1:50. 11:50, 12:50. 1:50. Shall we take one more question? Let us try one more question. As time is there. You are taking class seriously, then I'll take one more question. Come on, type there. मिलेगा भैया, आपको मिलेगा, PPT मिलेगा आपको, जरूर मिलेगा. Why not? They will give you. Without students, there is no coaching centers. Students को जो चाहिए वो provide करना पड़ेगा coaching centers को, नहीं तो वो नहीं चलेगा. I am also speaking English. I am also speaking Hindi. क्यों नहीं करेगा? जरूर करेगा. सपोर्ट करना है स्टूडेंट्स को. Okay, then I'll stop here today. Again, we'll meet either evening today or tomorrow. Today evening or tomorrow. So before I conclude, so Unacademy is offering nice discounts to all of you. One discount is there, 30% discount they are giving on this subscription. Okay, you can enroll, make use of this. This offer ends today only. So this is a very good offer. Enroll as fast as you can and make use of this. So they are giving so much discount. So make use of this. Last day of the offer. This last day of the offer, and avail this offer and save your money. The savings is almost 30%, more than 30% sometimes. It's almost 30% offer. Very good offer it is. Both in iconic subscriptions and plus subscriptions, both they're offering this. Kindly enroll. Use my code GATE Civil. Okay then, we'll meet again tomorrow, same place, same time. Maybe around 4 o'clock I'll take tomorrow. We'll learn more about hydrographs. So until then,